Alright, so I'm going to pick up where I left off at the end of that last video, and I'll send this one out when I'm finished with it. So we've been talking about the power rule and derivative rules and all that good stuff. So I got a couple other examples I just want to mention here before we're finished. So let's try another example. I just did one where I had a negative exponent. I'm going to try one now with a fractional exponent. And I'm also going to look at the graph here for this one. So let's say that we had f of x equals the fifth root of x squared. All right, and let's say that I told you to find f prime of 0. So what I would recommend on this problem is, before I worry about the 0, and again, remember I could write this notation a couple different ways. I could say find f prime of 0, or I could also say find d dx of f of x. And I could put a bar right here, and I could put at x equals 0. These notations mean the same thing. All right. So anytime that you get any of these problems where you have to evaluate a derivative at a point, the first thing you should do is worry about taking the derivative itself. Okay. Great place to start on this problem is rewrite the fifth root of x squared as x raised to the 2/5 power. Because once you rewrite it like this, it's much easier for you to use the power rule to find your answer. So let's try it. If I multiply this 2/5 to the front, I get 2/5 times x, and then I'm going to subtract 1 from the exponent. When I'm done, that gives me 2/5 minus 1 is negative 3/5. So I would accept that as a final answer, but if you wanted to go a little bit further, here's what you could do. You could rewrite this as 2 over 5 times on the bottom, make this exponent positive, so x to the 3/5. And this is the same thing as 2 over 5 times the bottom number is the root, so the fifth root of x cubed. So here's the derivative of that original function. Okay, now if I try to find f prime of 0, we'll notice there's an issue here. So I'm picking this problem because I'm going to show you what the graph of this looks like in just a second. If I take the fifth root, 5 times the fifth root of 0 cubed, I get a 0 on the bottom. Okay, and I can't have a 0 on the bottom and a non-zero number on top. Therefore, what we'd have to say right here is f prime of 0 is undefined. Okay, but I would like to examine this visually real quick, and I want us to think about why f prime of 0 might be undefined. So let's look, first of all, at the graph of the fifth root of x squared. That would be x to the 2/5. So this was my original function. So what you'll notice here is, as I approach 0, it looks like the tangent line might be something that's undefined. Okay, because it looks like if I drew a tangent line right here, it would be a vertical line. All right, like a straight up and down line. So like if I just put x equals 0, we can see like the line x equals 0 looks like it would be tangent to this graph at 0. So the reason why the derivative doesn't exist there is because there's a vertical tangent line. And so we learned that if there's a vertical tangent line, something is said to be not differentiable at that point. Now, if you think about the graph of the derivative is this, 2 divided by x raised to the 3/5 power. And what you'll notice is on the derivative function has an asymptote at 0. And the reason why there's an asymptote there is because the derivative does not exist at 0. So the derivative function does not have a value at 0. And this kind of makes sense because we've learned in order to have a vertical asymptote, you have to have a non-zero number up on the top, and you have to have a 0 on the bottom. And that's exactly what's happening here. Therefore, the derivative is undefined. And when we look at the derivative function, there is a vertical asymptote. All right, I've got two other examples I want to show you. Before I do that, I want to rewrite the definitions of derivatives here so we can look at those definitions. And then we're going to do a problem combining the power rule with these definitions. First question when you take your assessment is going to be, what are the definitions of a derivative with limit notation? So here's the first one. The formal definition says f of x plus h minus f of x divided by h. And then this is to find a derivative function. And then to find the derivative at a point, we can use this. F prime of c equals the limit as x approaches c of f of x minus f of c divided by x minus c. All right. So why am I writing these down? Because now we can answer more complicated questions with these using the power rule. So here's an example. Let's say that I saw this limit here. Let's say I said, what's the limit as x approaches 3 of 2 x cubed minus 54 divided by x minus 3. Now, what I don't want you to get in the habit of is thinking that every single time you see a limit, it's asking you about a derivative, because that might be the case, it might not be the case. However, if I told you to evaluate this limit, one way that you can do it is, I can see, does this limit right here fit the pattern of either one of these limit notations for a derivative? And so if I was trying to figure this out, the first thing I might ask myself is, what does this look more like, the formal definition or the informal definition? When I glance at this, the first thing I think is this looks more like the informal or the alternate definition of a derivative, which looks like this: f of x minus f of c divided by x minus c, and I take the limit as x approaches c. So if I asked you first, what does this mean? What you could say is, pose the question, what does this mean? What we could say is, well, this might mean f prime of blank if f of x equals blank. And if I look at this, just fitting into the pattern, this would be f prime of 3 if f of x equals, well, here's f of x, 2x cubed. Now, you do want to make sure it fits the pattern perfectly, but guess what? This number right here should be whatever I get when I plug c, which is 3, in for x. And guess what? If I try f of 3, 2 times 3 cubed, well, 3 cubed is 27, times 2 is 54, so this checks out. So this limit right here is just asking me to find the derivative at 3 for the function f of x equals 2x cubed. And now that we know the power rule, I don't have to do any sort of crazy math with this to find my answer. I don't have to make a table. I don't have to graph. I don't have to do any factoring. I can just use the power rule. So let's try it. If I wanted to find f prime of x here, multiply the 3 to the front, I get 6x, and subtract 2 from that, or subtract 1 from the exponent, I get 6x squared. And then last but not least, if I try f prime of 3, 6 times 3 squared is 9, 6 times 9 is 54. So that means the value of this limit is 54. So this is, again, another pattern matching thing where I'm fitting the pattern of the formal or the informal definition of a limit in and figuring out what it means. And then once I figure out what it means, I can use the power rule to evaluate. All right, one more, and then I will be finished, I promise. So same idea here. Let's take a look and see if we can come up with something. Let's say we wanted to know what's the limit as h approaches 0 of, limit as h approaches 0 of, let's try 9 plus h to the 1/2 minus 3 divided by h. Okay, and once again, I'm going to say let's evaluate this. And again, I don't want you to get in the habit of thinking that every single limit you ever see is talking about a derivative. But it might be, and if it does, then we need to be able to recognize the pattern and write what this means and then evaluate the derivative. So as I look at this, if I ever see the limit as h approaches 0, I'm thinking that maybe, not necessarily, but maybe this fits into the pattern of f of x plus h minus f of x all divided by h. And so if I'm trying to think about what this means, maybe this means f prime of blank if f of x equals blank. And so I'm going to take a look at this. I'm going to see if I can fit in some of this information. So when I first glance at this, what I see is something being raised to the 1/2 power. So my guess is that this function might be the square root of x, which is the same thing as x to the 1/2 power. And this makes sense because if I was going to do f of x plus h, and f of x was the square root of x, well then f of x plus h would be the square root of x plus h, which is x plus h raised to the 1/2. And that's kind of what I'm seeing right here. But if we think about what the x value is, well, the x value is 9. So this is what this is asking me here is, what's f prime of 9 if f of x is equal to the square root of x? This also makes sense because if f of x is the square root of x, if I plug in 9 for x, guess what I get? The square root of 9 is 3. And so all of this is making sense. And so once I figure this out, now I can do the rest of this math. If I want to find f prime of x, and the derivative is, or the original function is x to the 1/2, I would multiply the 1/2 to the front, subtract 1 from the exponent, I get 1/2 times x to the negative 1/2. And then when I'm done right here, I can move this to the bottom, write this as 1 over 2 times x to the 1/2, which is 1 over 2 times the square root of x. This might be something that you want to memorize. I would encourage this because this particular derivative is going to come up a lot this year. If f of x is the square root of x, the derivative will always be 1 over 2 times the square root of x. It'll kind of allow you to skip this, and this if you know to go straight from here to here if you're taking a derivative. With all that in mind, now I can plug in 9 and I can get a final answer. So this is when I'm done going to be 1 over 2 times the square root of 9. 2 times the square root of 9 is 2 times 3. So my final answer here when I'm done is 1/6. So what does that mean? The value of this limit right here is equal to exactly 1/6. All right, hopefully that makes sense. Let me know if you have questions. I'm going to post the Khan Academy now. See you later.